integration by parts. Here we're going to look at just starting off with the product rule and deriving the integration by parts formula. So if we have two functions in terms of x, u and v, and we derive them, so finding the derivative with respect to x, we know that we get v du plus u dv. And all we want to do here is just integrate both sides, which means we're finding the integral of all of these terms. The integral of d dx of uv is just uv. And we can just leave these as the integral of v du plus the integral of u dv. Let's go ahead and make the integral of u dv the subject. So we get the integral of u dv is going to equal uv minus the integral of v du. And this is the integration by parts formula, which is saying that if we have the integral of u multiplied by some dv, we can find the integral using this formula. So how are we going to go about using this? Best way is probably through an example. So if we have the integral of x times e to the x dx, you want to pick something where one thing we're going to have to differentiate and one thing we're going to have to integrate. Here, and the thing you want to differentiate will let equal to u, and the thing we want to integrate will let equal to dv. So here we're going to let u equal to x, and we're going to let dv equal e to the x dx. So we're taking this part here and letting it equal u, and this part here and letting it equal dv. Let's go ahead and find du dx. That's just going to be 1. And let's go ahead and find v by taking the integral, and we get e to the x. Now we know that this can be written as u times v, so we're going to get x times e to the x minus the integral of v du. Now v is just e to the x, and du, you can imagine the dx going over there, so du actually equals dx, so du is equal to dx, and we can see this is easy now to evaluate because we get x e to the x minus the integral of e to the x is just e to the x plus a constant. And if you want, you can factorize out that e to the x and get e to the x outside of x minus 1 plus a constant for that answer. So look at another example. We've got the integral from 0 to 1 of x squared e to the minus x dx. And we need to let u equal to something, and we need to let dv equal to something. So the goal here is to, again, try and get something, pick something for u that's easy to derive and something for dv that's easy to integrate. So here we're going to let u equal to x squared, and we're going to let dv equal to e to the minus x dx. So all of this part is equaling u, and this part is equaling dv. So let's go ahead and derive. So we get du dx is equal to 2x, which means that du equals 2x dx. V, we're just integrating, so we're going to get minus e to the minus x for our integral for v. So let's go ahead and use the integration by parts formula. So remember, that's the integral of u dv equals uv minus the integral of v du. So u times v, we're going to get minus x squared e to the minus x minus the integral of v, which is minus e to the minus x times du, which is 2x dx. We can tidy this up a little bit, so we get minus x squared e to the minus x. The minus we can take out the front, so make it plus. So this is the integral from 0 to 1 as well, because this is a definite integral this time. 0 to 1, so we took the minus out the front. We can take the 2 out the front as well, and we get x e to the minus x and dx. And here we still can't integrate this, so we need to do an integration by parts again on this part. So here we're going to let u equal to x and dv equal to e to the minus x dx. So we'll differentiate u, du dx is equal to 1, so du equals dx. We'll integrate both sides here. The integral of dv is v. The integral of e to the minus x is minus e to the minus x. And we can go ahead and do the integration by parts formula again. So we get minus x squared e to the x, e to the minus x, so we still can't forget about that part, plus 2 times, now the integral here, we're going to get u times v, so we're going to get minus x e to the minus x minus the integral from 0 to 1 of v du, which is just going to be minus e to the minus x of, and times dx. So we should have these wrapped in definite integrals as well, 0 and 1 and 0 and 1. So we're constantly evaluating those integrals when we have definite integrals. So here we're going to get minus x squared e to the minus x from 0 to 1 plus 2, all outside of minus x e to the minus x from 0 to 1. Now the integral of this is easy because we can take that minus out to the front, so that becomes plus. And the integral of e to the minus x is just minus e to the minus x from 0 to 1. And all we have to do now is evaluate all of these integrals. So now we can go ahead and sub in all these values. So subbing in 1, we get minus e to the minus 1 minus, subbing in 0, we're just going to get 0 plus 2, all outside of subbing in 1 here, we're going to get minus e to the minus 1 minus 0 after subbing in 0 plus subbing in 1 here, we're going to get minus e to the minus 1 minus subbing in 0, this time we're going to get minus 1. Just tidying this up, we're going to get minus e to the minus 1 plus 2 outside of, now we've got minus e to the minus 1 minus e to the minus 1 is going to be minus 2 e to the minus 1. Then we've got our minus 1, which turns into plus 1. Let's tidy this up. So we've got 2 times minus 2e to the minus 1 is minus 4e to the minus 1. Then minus e to the minus 1 minus 4e to the minus 1 is minus 5e to the minus 1. And we've got 2 times 1, which is 2 for our final answer. Let's have a look at another example. So here we're actually going to integrate ln x dx for the the first time, and we can use integration by parts to do this, where we're going to let u equal ln x and dx equal to dv. And here it would be silly to let ln x equal dv, because that'd just be the original question, because we'd just be asking to how do we integrate ln x. So if u equals ln x and dv equals dx, du dx is going to be 1 on x, which means that du will equal 1 on x dx, and v, integrating both sides, we're just going to get v equals x. Let's go ahead and use the integration by parts formula, where we have the integral of u dv, we know is going to equal to uv minus the integral of v du. So u times v is just going to be x times ln x minus the integral of v, which is just x, and du we know is 1 on x dx. So here we're going to get x ln x minus the integral, or x times 1 on x is just 1, and we're just left with dx. So we get x ln x minus the integral of dx is just x, and we get plus a constant. So there it is, the integral of ln x. We'll do one more similar example, looking at the integral of the inverse sine of x dx. And we don't know the integral of inverse sine of x. We know that the integral of 1 over the square root of 1 minus x squared is inverse sine of x. And I'm going to take a similar approach and let this equal u and this equal dv. So u is going to equal the inverse sine of x, dv will equal dx. So here we can find du dx, which we know is 1 over the square root of 1 minus x squared. Integrating both sides here, we're just going to get v equals x. And we know the integral of u dv is going to equal uv minus the integral of v du. So u times v, we're just going to get x times the inverse sine of x minus the integral of v du, where we're going to get x over the square root of 1 minus x squared dx. Let's try a substitution here. We'll let u equal 1 minus x squared. So du dx equals minus 2x. So dx equals du over minus 2x. So we're going to get x inverse sine of x minus the integral of x over root u times dx, which we know is du over minus 2x. Get x times inverse sine of x, integral of the x's cancel out, and we can pull the minus a half out, so it becomes plus a half. And we can rewrite 1 on root u as u to the minus half du. So we get x inverse sine of x plus a half times the integral of u to the minus a half is just going to be adding 1 to the power and dividing by that power plus a constant. So we're going to get x times the inverse sine of x. This half and this half will cancel out, and we need to sub u back in. So we're going to get plus the square root of u, which is 1 minus x squared plus a constant.